So if I know two angles are congruent in one triangle, what kind of triangle is that? Ooh, only two angles are congruent. Isosceles. So let's make an isosceles triangle. And it says angle A is congruent to angle C. And that will be B right here. So that means what two sides are congruent? AB and BC. So I'm going to find AB. AB is right here. And let's find BC. Those two are congruent. So let's set them equal to each other. 3x plus 5 is equal to 2x plus 8. And I'm going to say minus 2x on both sides, which gives me x. Minus 5 on both sides, we get how many? 3. And it says to find the length of each. So I'm going to put on here, we have AB is equal to, BC is equal to, and AC is equal to. Since AB and BC are both congruent, does it matter which one I plug it into? Not really. I feel like the first one. 3 times 3 is 9 plus 5 is how many? 14. Because it is isosceles, BC is also 14. What would AC be when I plug it into this guy right here? 5. Done. Okay, the next one we're working on, number 12. Okay, Chapman, let's read number 12.
The measure of the angles of the triangle are represented by 11x minus 14, 5x plus 13, and 8x plus 13. Find the measures of its angles.
So what do I know about the triangle sum? 180. So let's set them all equal to 180. So I have 11x plus, not plus, it's not minus. Oh goodness. Boom. Minus 14 plus 5x plus 13 plus 8x plus 13 must equal how many again? 180. Let's go ahead and simplify the left side. How many x's do I have total? 24, very good. When I combine the constants, how many do I have? 12. So now let's subtract 12 on both sides and divide it by 24. It should give you a clean single digit. 7, very good. And it says to find the measure of each angle, so I would need to go ahead and plug it into this guy here, and this one. Okay, someone plug in 7 into the first one and give me how many? It would be 77 minus 14. How many? 63. Okay, let's plug it into the second one. 5 times 7. 48. And then the last one is how many? And for us to double check on this, when I add all three of them, it should be equal to how many? 180. Okay, if you want to check. So now let's go on to number 15. 15 says, is it possible? If so, draw an image. Is scalene isosceles contradicting? Yeah? So we know this is not possible. Could I have an obtuse right? Nope, that's also contradicting. Could I have a scalene that's acute? Okay, so let's write yes on this one and draw an example. And I want to make an example with specific numbers just because it's a little more concrete. Let's say I have 70 degrees up here, 60 here, and 50. When I add those three angles, does it give me 180? Yep. What about obtuse isosceles? Is that possible? Yes? Let's do an example. I don't know why I wrote yes with double S's. Oops. So obtuse isosceles. So here I could have 100, and here I could have 40 and 40. That makes it isosceles and obtuse. Could I have an acute right? Nope. What about obtuse scalene? Obtuse scalene. So I can make all three sides different, and can one of them have an angle that's greater than 90? Okay, let's try one. It is yes. I'm gonna make one like this. So we have 100 degrees. If that's 50, that makes this 130. That means this side is not the same as this side, nor the other side. Good? All right. Number 16. Let's start with the givens. We have AE is congruent to DE. What's the reasoning for this one? Given. So AE is right here, DE is right here. And I'm going to write S to represent the sides are congruent. Let's go on to the second given. It says angle EBC is congruent to angle ECB. That's also by the given. So we have EBC right here and ECB right here. So this one's a little bit awkward, because our final goal is to say that AB is congruent to DC. AB is congruent to DC. So what kind of triangle is this right here? Just that bottom piece. Ooh. If two angles are congruent, we know for sure it's got to be what? Isosceles. So could I say the opposite? Angles are also congruent like that? Yeah? So let's put on here that BE, these two are directly related right here. BE is congruent to CE. And that was one of the theorems that we wrote back in, I believe, 4.4-ish. And it was, if two angles in a triangle are congruent, then I know what sides are congruent. The opposite sides. And the order does matter, because if you notice on number two is stating angles, so I must state that first. And statement number 3 says, my sides are congruent. So the order does matter. Okay? All right. So then, if I were to highlight the two triangles that are going to be congruent, it's going to be these two triangles. Between those two triangles, do I see a reflexive or vertical? Vertical angles are always what? Congruent. So I'm going to put A as an angle, and I forgot the side over here. So we have, for the vertical angle, we have to use 3 letters. So if I start the first one as AEB, it's congruent to. How would the other order be? D, EC. And that's because vertical angles are congruent to. So now I know the two triangles are congruent. Triangle AEB is congruent to triangle DEC. By what? Side, angle side. And then from 4.6 on your notes, we can use CP, CTC after two triangles are what to each other? Congruent. So corresponding parts of congruent triangles are congruent.